Welcome to our channel. In this session, we are moving to the program Symmetric Tree. Read the question carefully. Given the root of a binary tree, check whether it is a mirror of itself. Mirror of itself. What is the meaning of this one? Suppose if you see the tree, in left subtree and right subtree, both are appear in the mirror fashion. Now observe one. What is the left child of 1, 2? What is the right child of 1, 2? Both are same. Similarly, for 2, the left child is 3, right child is 4. In the mirror, the left becomes right and right becomes left. Here observe, in the right side 2, the right child 4 becomes the left child. The left child 3 becomes the right child. How they given? See, 1, 2, 2, 3, 4, 4, 3. In the list format, level by level, they are given the value. Here also observe 1, 2 is the left, 2 is the right. For this, no problem. 3 is the right child of 2. In mirror, the 3 comes as the left child, but here the 3 comes as the right child only. In the mirror, the positions must and should be changed. So this is not a symmetric tree. So what is the output? The output is false. Now you got the point. Now we will discuss. See this example. What they given? 1, 2, 2. Here the left one is 3, the right is 4. Here the left is 4, right is 3. Now you need to check the conditions, what they are given in the question. Now move to the question. Now coming to the question, they given the root. What they given? They given the root. At the same time, for the root, you need to check left and right. Remember, in the previous example, I am using same p dot left, q dot left. If you are using that fashion, it is very simple. Means I am dividing the tree into two parts. Assume this is p and this is q. Then it is very easy to write the program. Now, how do I write the program? I am taking two parts P and Q. Suppose the first condition, if not P and not Q, same, written true. Means if P is null and Q is not null, it returns true. Suppose exactly if not P or not Q, return false. Anyway, these are the base conditions for verifying the structure. That is the structure of P and the structure of Q. Now observe carefully. Here first this is the P value, this is Q value. Here if P dot value is not equal to Q dot value, if these are not equal, what you need to return? False. Now the next thing is P is moved to the left side. Now P dot left, P move to the left side. Now Q move to the right side. Q move to the right side. In the next iteration, I am checking these two values. That is the left side of P is equal to right side of Q. And what you need to check? The right side of P is compared with the left side. This is the right side of P. This is the left side. Now you got the point. In the previous example, our program is same tree. That means the left and left are equal. But in this example, symmetric tree means the left is equal to right. The left is equal to right. Anyway, here P points to 2. So obviously P is some true. Not P means false. If false and false, if both are false means nothing is there. If nothing is there means obviously return true. If at least one is present, return false. Now you got it. For that, how do I change the program? Observe. Only root is given. Instead of that, I am defining my own function. It is possible also. Suppose I return a function identify of P comma Q. I am taking two values P comma Q. Now, what is the p value? What is the q value? You need to pass. You need to pass. Suppose if I pass, if not p and not q, obviously not p means if p consists of any element, that is true. Not p means it does not consist of any element. Similarly, q also does not consist of any element, return true. If not p or not q, return false. Okay, the same logic we written in the same tree also. Now what you need to check, p dot value is compared with q dot value. If at any point if the values are not equal, what I return false. Okay, now repetition, that is recursion, self dot, what is my program? Identify. My function name is identify of p dot left. Here observe in the diagram. Initially my assumption, right now you don't know. Again I will repeat. See, assume this is the tree. 1, 2, 2, 3, 4. 4, 3. So assume this is p value, this is q value. Here what I check? P dot VAL is not equal to q dot VAL. Yes or no? No. P dot VAL value is equal to 2. That is right. Q dot VAL value is also true. That is also right. Now I am comparing this. What is this one? P dot left. In the next iteration, I need to compare this one with mirror image with this one. What is this one? Right. So you got it. So p dot left comma q dot right. End. At the same time, after completion of all the left, so this is the p. I am comparing this p. That is p dot right is compared with q dot left. And self dot identify of p dot right is compared with q dot left. Now, this is the program for symmetric tree. Here you need to know one more thing. What is the point? Sir, how do you identify fix? This is the p value and this is the key value. In the question they given this one. Root only they given. Root only they given. Now, root to dot left is the p value. Root to dot right is the q value. I assumed like this. In this function, in this function, return identify of root dot left comma root dot right. Now observe, first to happen within this function. Anyway, this function definition is not at all executed. You know, but whenever you are calling, that only executed. This is inside def is not executed. Directly it comes to this return statement. Directly it comes to this return statement. Observe this return statement. In this return, I am calling the function with root dot left and root dot right. Now the root dot left is passed to p and root dot right is passed to q. Now you got the point. This is the way I return the logic. Now run this program. Run this program. Yes. All the test cases are accepted. Just to full stop comma mistake only. Now submit the program. Yes, fine. All the test cases are accepted. This is the concept of symmetric tree. Thank you.